Okay, so now let's go through some special forms of the energy equation. Wow, that was a really hard derivation. Glad we did it together. You're like, what derivation? Okay, I didn't do the derivation. It's super long. It's super long. And in the end, all you do is you get to these equations. These are great. These are absolutely fantastic. And more than that, guess what? There's an entire appendix that already tabulates all these equations for you. Now, before I jump and show you where that appendix is in your textbook and talk about how I actually use it, let's look at these equations. So what they give me is my ratio of my stagnation property to my static property as a function of Mach number and also as ratio specific heats. So I have those for temperature, for pressure, and for density. Okay. I was really worried I had a typo here and then realized, there you go, that's the change. So if you know your Mach number, you know these ratios. Interesting thing, if you're going Mach 0, well, that ratio is 1 for all of these. Okay? If you're going something else, then it changes. What you'll find is that for pressure and for temperature and for density, as you get to higher and higher and higher Mach numbers, this ratio gets bigger and bigger and bigger. It jumps up dramatically. That's telling you how much energy you have more or less stored in your flow versus stored in just the static modes. Okay, now where do you find the appendix in your textbook so you can more or less ignore these equations, or if you would want to ignore them, make a calculator yourself? I'll go ahead and show you now. So here we are in the textbook, and so what I'm going to do is I'm going to go up here, go to Contents, and scroll down to the appendices. I'm going to go to Appendix A. Because all those equations for isentropic flow. Those equations that I showed you, only for isentropic flow. When we experience isentropic flow, we experience isentropic flow before a shock wave or after a shock wave, but not across a shock wave. And so here's my appendix. You can see the ratio of pressure, density, temperature, and also this thing which we'll talk about later in the course. And you have your Mach number on this side. And so you can see that there's a Mach number of currently 0.02, and I go up there, now it's a Mach number of 0.2, and then I go higher up here, Mach number of 2. Be very careful, that's times 10 to the power of 1, so this is 0.2 times 10, which makes it 2. And I gotta look across here as well, so this is not 0.7824, it is 7.824. So if I wanted to find out my stagnation pressure at a Mach of, let's say 0.5, and I know my static pressure, I can do that. I can just look up, okay, go to a Mach number of 0.5, it's right here, I go across, my ratio is 1.186, and I would then use that to find my stagnation pressure, or temperature, or density. And so the tables make this really, really easy. If it's in between, you can interpolate to find those values, or if you want to, you can go ahead and make an equation or some sort of calculator using the equations. They're very simple for this table at least, so it's not that hard to make a calculator. So that's it for this time. Next time we're actually going to jump into a video using an example where we start using these equations to solve things. But hopefully this helps you. You can find where you find these in the textbook. And remember, it's isentropic flows, only before or after a shock wave, not across a shock wave, because shock waves are entropy generators. Thanks for listening. See y'all later. Bye-bye.